All right, let's get started with 1.4. This is the last lesson for the week, so your test on Friday is going to cover all of this. Because it's the last lesson for the week, you will have access later today to the videos for the solutions for 1.4. And then tomorrow, you'll be taking your test. So the smart thing to do before your test is go back through any homework that you didn't understand. Make sure that you're familiar with the vocabulary in your notes. And highlight, if you've been highlighting any problems that gave you trouble, then make sure you watch the solution videos for those in preparation for the test on Friday. What we're doing today is really similar to what we did yesterday, except yesterday we just transferred our words, our verbal phrases, into expressions. Today we're going to be doing equations, which will have equal signs, or inequalities, which will be using these symbols. And so there's going to be an extra layer to what we did yesterday. So the vocabulary, an equation is just simply going to be an expression again, but this one's going to contain an equal sign. And so an equal sign is going to often replace the word is, like 2x is 8 would look like that. So the is will often indicate you're going to be using an equation, equal sign. Inequality, you're going to be using less than, meaning it has to be less than that number. It can't actually equal it. Less than or equal to, so this is still less than, but it can also be equal to. So less than 10 means 9, but less than or equal to 10 means 10 and on down. Then we'd have strictly greater than, so you're looking for numbers bigger than the number. But if you want to include that number, you'd be doing greater than or equal to. So this is still greater than, but also or equal. So when you're looking for the solution of an equation, that just simply means a number that makes the equation true. So in the example that I put up here, x equals 4 would be a solution because it makes that true, whereas x equals 3 wouldn't, because 2 times 3 is 6. Same thing here, the solution of an inequality is still going to be a number that makes the inequality true. So you're going to have to test that. You're going to plug the number in and you're going to see if it results in a true statement, then you call it a solution. If it does not, then it's not a solution. So here's going to be some of the wording that you might see. So like I said before, it might say it is. It might say is equals to, the same as. And so that's when you're going to use an equal sign. If it straight up says less than or fewer than, you're looking at a less than sign. Is less than or equal to, at most, no more than. Those are the phrases. Like if you're going, you say, can I have some cookies? And your parent says, well, no more than 3. That means you could have 3 or 2 or 1 or none. If they said you have to have fewer than 3, then you no longer have the option to have that third cookie. You would have to have 2 or 1. So be cautious about when it adds in that equal sign. Same thing with greater. More than 5 is different than at least 5, because more than 5 means you'd have to have something bigger than 5, not actually 5. But if you said at least 5, then you could have 5, 6, 7, or 8. So this one doesn't include it, but this one does include that value. So you have to be a little careful when picking between greater than or greater than and equal to, less than and less than and equal to. You really have to think about what the words mean that you're reading. So for example, difference. So this is going back to what we've already talked about yesterday. Difference is indicating subtraction, twice a number k. So when you do twice a number k, that's going to be doubling the k. So the difference of twice a number k and 8 is, there's the key word, 2. So twice a number k and 8, the difference, that's how I knew to use subtraction, is 2. So writing that equation is always really tricky, and so make sure that you're really practicing along with this, because this is a skill that I find that the high school kids struggle with. Product, key word, that's telling me I'm going to be multiplying. 6 and a number n, so I know I'll need a 6n. And then it says is at least 24. Can it be 24? If it says is at least 24, yes, it's at least 24, but it could be greater. A number y is no less than 5 and no more than 13. Wow, that's kind of tricky. So it's in between two numbers. So if it has to be no less than 5, it has to be greater than that. Can it be 5? If I say no less than 5, then yes, it can actually be 5. It just cannot be less than that. And this is a greater than symbol. It's read as that because it's opening towards the y. So that's tricky because the letter is on the right side. Y also has to be no more than 13. So that would have to stay less than or equal to 13. Keeping in mind that when you have these, the numbers go in number line order. So the 5 has to be over here to the left. And then the 13 would go over to the right like it would. And then those alligator mouths continue to open to the right towards the bigger number. That all goes back to this combining inequalities. Sometimes two inequalities are combined. So here where it had to be both things, it had to be this and that. You can write them differently. So another way you could write this, you could have said y is no less than 5. So you could have written it as y has to stay greater than or equal to 5. That's no less than. And it also has to be less than or equal to 13. That would be another acceptable way to write it. So you can see here they wrote this expression two different ways. So whichever of these makes the most sense to you, that is fine with me. Both of those, as long as you have that and written in there. So I know you know it has to be both things. Write an equation or inequality. Okay, quotient. So I'm thinking division of a number p and 12. So I'm going to do p divided by 12 and then is at least 30. Can it be 30? Yes, if it has to be at least 30. So greater than or equal to 30. Or my other option would be p divided by 12 greater than or equal to 30. Because that's the same thing. It says the quotient of a number p and 12. And so whether you write it as a fraction or you write it as a statement like this. And this just says to write an inequality. I'm not looking to solve it. So I either can write this and be done or that. When you substitute a number for the variable, meaning you plug it in an open sentence, meaning there's x's or y's, the resulting statement is either true or false. So this is saying that you're going to plug in a number for the x, the y, the z, whatever variable they're using. And then you're going to look and you're going to say, does it make the equation? So you started with an equal sign, or it might have been an inequality. So does it make the equation or inequality true? Then you would say it is a solution. If it makes the inequality false, then you would say it is not a solution. So you're going to plug it in and check it. That's how you're going to determine if something is a solution. So let's try that. Here we're trying to find whether or not 3 is a solution. So what that means is plug in 3. Is it true or is it false? If it's true, that's a yes solution. If it's false, then no, it's not. So for example here, I'd have 8 minus 2, plug in my 3 for x, and I'm questioning whether that will equal 2. Well, what we've learned about math is I have to do the multiplying first, so I get this. And so then here I get that 2 equals 2. So yes, 3 is a solution to part A. In B, I'm putting the 3 in for x because I'm testing that one out. I'd multiply before I subtract. So I end up with 7 equals 6, which is not true. So then 3 is not a solution. How about C? Still plugging in a 3. It doesn't matter whether it was an x or a z in this case. I'm plugging in 3, and then I'm going to multiply first because I still have to stick with, my PEMDAS. Oops, that's so messy. Sorry. So this will be 6 plus 5. So my statement is that 11 is greater than 12, which is false. So no, 3 is not a solution. So it did work in A, but it did not work in B or C. How about in D? In D, I'm going to be putting in my 3, trying to stay less than or equal to 20, still sticking with PEMDAS. I have to do my multiplying first. Adding those together, I get 14 is less than or equal to 20, which is true. So yes, it is a solution to D, and it was a solution to A, because when I plugged it in, it created a true statement. So here we're going to be solving. So instead of just plugging in a number they gave us, we have to think, what is it looking for, and then find a number and then check it by plugging it in. So we're trying to do mental math. So we're not trying to solve it on paper. So here I'm thinking, what number plus 4 will equal 10? So I kind of think backwards and I say, I think that's going to be a 6. And then I check it by plugging it in and confirming that 6 works. So stop the video for a second, try the others, and then you can start it up again and see how you did. Okay, so hopefully you tried these on your own. This one you're thinking 20 minus what is going to equal 8? So 20 minus what will give me 8? So think backwards. And I'm going to come up with 12. And I'm going to test it by taking 20 minus 12 and confirming that that does give me 8. Here, 6 times what, because the n is unknown, is 42. So thinking backwards, I decided on 7. And then I test, does 6 times 7 equal 42? Yes, it does. So 7 is my solution. On the bottom problem, I'm asking what divided by 5 will give me a 9. Thinking backwards, I'm getting 45. And I check by looking at 45 divided by 5 and confirming that it gives me a 9. So just trying to exercise my brain cells and do some mental math. Now, this is guided practice, so it's going to be asking you to do what I already did. Stop, go through, and then come back and check to see if you did the right thing. Okay, hopefully that made sense. Otherwise, go back and look at the notes again. Here's some more guided practice where you're going to be using the mental math and thinking, trying to come up with a solution, and then showing that you can check your work. So take a minute to do that and see how what you're doing compares to what I'm doing. Okay, so good mental math stuff. All right, the grand finale is always the best part. We're going to take a look at example 4 where we have to put everything we've learned kind of into action together. We're going to look and see, what do I do with all these words and turn them into an equation, and then probably have to solve those too. So let's take a look at that. So the last time you and 3 friends went to a mountain bike park, you had a coupon for $10 off. So kind of keep that in mind. You paid $17 after using the coupon for the 4 tickets. What is the regular price of 4 tickets? Let's take one question at a time because we've got a couple different questions. So we were looking for the regular price. So let's have P equal our regular price. So the regular price is going to be, if I think backwards, the regular price minus my $10 coupon landed me at a $17 charge for the 4 tickets. So if I think backwards, what minus 10 is 17? And the answer to that would be 27. So that means my regular price is $27, and that is for 4 tickets. Because the information that I had, I can't spell apparently, the information that I had was about 4 tickets. Alrighty, then what is the second equation, or excuse me, the second question? The second one is saying, if you pay the regular price, which we now know is 27, and share it equally, how much does each person pay? Okay, so X is going to be each person pays however many dollars. Keep in mind you're going with 3 friends, but that's you also. And so in the end, much like the example we had the other day where there were tips that were being divided, we're going to be looking and saying, okay, each person is going to get the regular price for 4 tickets, which was 27, divided by the number of people there are. And so that's going to be 4 total. So if we pitched in and took 27 divided by 4, then we would find out that each person has to pay $6.75. And I always want to label my answers so they make sense. So somebody looking at this can say, okay, it costs $27 for 4 tickets, and that leaves me paying $6.75 per person. Okay, so we are at the 1.4 mark. So keep in mind that there's going to be a test on Friday, which is tomorrow, on 1.1 through 1.4. Like I always say, you want to be prepared, not scared. So how do you do that? Well, I would look back over the solution videos. If you look in each day, they're called homework help. So if there's anything you didn't understand, watch the homework help videos. The other thing you can watch is it actually has a solutions page that's posted each day after. So if we do 1-1 on Monday, then you'll see the 1-1 solutions on Tuesday, so the following day. So look through that. You might want to look through your notes, taking a look at any vocabulary, making sure that you understood the examples we did and so on. But specifically for today, practicing what we did today, you're going to be looking at the book page 24, 3 through 9 all, 12, 14, 19, 25, 29, 31, 34, 35, 41, 43, 46, this one's kind of a doozy, 54, 56. And then keep in mind for that test tomorrow, make sure you check the daily plan, find out when is the time that it's open and how long do you have. How long do you have to take that exam? So make sure you're looking for that information and then be ready to sit down and write out your work. I may have you submit a picture of your work along with your quizzes. So you would have to make sure that you have a piece of paper out. It would have your name on it. You would say test 1.1 to 1.4. Sorry, got ahead of myself there. And so then you would have to number the problems that you worked on. You would show your work and you would box in your answer. And then you're going to take a picture of that and send it to me. So you're going to send via Schoology. So when you look in the Friday folder tomorrow, you're going to see a place to submit your picture and then a place to take the quiz. And make sure you're practicing integrity because you do get a 0 if it looks like you copied papers with somebody else. So take your time, get ready, be prepared, and really do awesome, guys. Thanks.